Hello, my practitioner learners. So before I get into the practitioner introductory workshop that you're going to have to do to prepare when you actually come in for your check-in 3, I just want to review going from Vertex's standard form just to make sure you understand it, since you were able to test out of the novice and the apprentice workshop. So here are the steps. We're going to expand our binomial using the box method, distribute the number in front of the parentheses, and then combine like terms. So here's a function I want to change into standard form. Right now it is in Vertex form. So generally what I want to do is first expand out this binomial. I know x plus 7 squared is just really x plus 7 times x plus 7. Therefore, it's binomial or polynomial multiplication. There we go. Which is when I use my box method. So I have x plus 7 and x plus 7. Then you just fill in your box. X times x is x squared. 7 times x is positive 7x. X times 7 is still positive 7x. And then 7 times 7 is 49. At this point, don't forget, we always combine like terms for our diagonals. So this is going to give us 14x. In fact, it's going to give us positive 14x. So if we put it all, as a single line, so it's not looking like a box, we're going to write x squared plus the 14x we combine like terms of, plus the 49. But that's not our answer. Notice we didn't do anything with this minus 3, nor did we do anything with that minus 1. So we're going to bring it down. Minus 1, minus 3, j of x. So we did step 1. Step 2 now is going to be distribute the number in front of the parentheses. So notice I still have this number in front of the parentheses. Even though I expanded out my binomial, I'm still inside of parentheses because there's still a number here. So I'm going to distribute that number to each number inside my parentheses. So negative 3 times x squared is negative 3x squared. Negative 3 times 14 is negative 42x. And negative 3 times 49 is negative 147. Now we didn't do anything with this minus 1, so I'm going to bring down the minus 1. Now we have j of x equals negative 3x squared minus 42x minus 147 minus 1. Now when we say combine like terms, we have to see if we have any like terms. So in this case, we only have a single number that has an x squared. This doesn't have an x squared, this doesn't have x squared, neither does this. So I will just bring down my 3x squared. Once again, this is also a number with an x, so there's nothing I can combine this negative 42 with, so I'm going to bring it down. However, I can combine these. They are both constants. So I can combine it to be negative 148. So j of x equals negative 3x squared minus 42 minus 148. This is my answer. This is standard form. Keeping in mind that standard form is y equals ax squared plus bx plus c. And notice the similarities. So that was just a quick review of the apprentice workshop that you were able to test out. Here's a neater looking example. You're going to hear my dog in the background. So here's the introduction for your practitioner workshop. So this is the prep work you need to do. So first off, when we're writing vertex form from 2 points, sometimes they'll give us 2 points and we have to write the equation. Well, we can write vertex form when we're given 2 points. If we're given the vertex and a second point. So you'll use a vertex form to fill in h and k. You will also fill in your a values, or you'll fill in the h and k variables, and you will fill in the x and y variable to solve for a. So generally, when they'll give you both of these terms, the h, k, x, and y, you fill in all the numbers to solve. So if we're looking here, notice they tell us that we have the vertex negative 6, negative 4, and our graph passes through the point negative 2, 12. What that tells us, oh, whoops, I just realized the answer is already put out. I'll explain it. So generally we have 2 steps. Plug in h, k, x, and y. Notice for vertex form, we have x minus h plus k and a y equals. When we're solving for a, or when we're writing equations and they give us 2 points, they'll give us 2 points, but they don't give us the a value. So we have to plug everything in to find that a value. So we were going to want to define things. I know a random point they give me. So for example, when it says it passes through this random point, that's going to be my x and y. So negative 2 is x, 12 is y. And my vertex is specifically h and k. So h is negative 6, k is negative 4. Then I'm going to plug it in where it goes, so in the corresponding spot. So for example, my y I said was 12, so I'm going to plug in 12 here. I don't know a, that's actually what I'm solving for. Then I have x, I said x is negative 2, so I plug in the negative 2, minus my h is negative 6. Now be very careful here. This is a minus here. Students will oftentimes, when they see negative 6, just say negative 2 minus 6. That's not the same thing. You do the minus, and if your number is negative, you also put a negative here. Squared plus my k value was minus 4, so I'm going to plug in a minus 4. I clean it up a little bit, so this is really 12 equals a, negative 2, double negatives, when you subtract a negative, it's really adding. So negative 2 plus 6 squared, and then when you add a negative, it's really just subtracting, so minus 4. So I cleaned it up. From here, I want to simplify it a little bit more, so I know negative 2 plus 6 is positive 4, and I know 4 squared is 16, so instead of writing a16, I just rearranged it to be 16a. Then I know I want to solve for a, so I have to get a by itself, so I'm going to add 4 to both sides. So 12 plus 4 is 16. I end up with 16 equals 16a. If I divide by 16 on both sides, I get a equals 1. But notice it tells me to write the equation, so I haven't written the equation yet. So now I know, let's see if I have a different color. I guess we can use this. A is 1. So if I think back to my original equation, y equals a x minus h squared plus k, I can start plugging in values. Now when we write our formula again, we do not plug in for x and y. The only time we plug in x for y, or for x and y, is when we're trying to solve for an a. In this case, leave the x and y. You do want to solve or plug in for your h and k, so I said my k is negative 4. And I said my k is, or my h is negative 6. Double negatives make a positive. And my a value actually turned out to be 1. So you can write 1, or you can just leave that blank because that's a redundant one, or what we call an implied one. So we can rewrite our formula as y equals x plus 6 squared minus 4. So by given 2 points, a variable and a random point that our graph passes through, we'll solve for a, rewrite our formula in Vertex form. So we'll do another example, this example together in class during your practitioner workshop. So I'll see you back in Zoom. You can log back into Zoom earlier if you want. You can start your homework. But if not, I'll see you in check-in 3.